Hi everyone, in this video we're going to be looking at more experimental and theoretical probability. So remember, experimental probability is the probability determined by actually conducting the experiment and recording the data. Theoretical probability is the probability determined by analyzing the experiment and predicting what should happen. So there's theoretical and experimental. So experimental is based on the experiment. Theoretical is what you expect to happen. So a bag contains 3 green marbles, 5 yellow marbles, and 2 red marbles. You choose a marble from the bag at random. Answer the following questions. Explain your reasoning. What is the probability of that the marble is green? The probability it is yellow? The probability it is red? Let's first start with green. So the probability of green. There are 3 green out of a total of 3 plus 5 plus 2, which is 10 marbles. As a decimal, that's 3/10. As a percent, 30%. The probability of yellow. There are 5 yellow out of the 10 total, so it's 5/10. That reduces to 1/2. As a decimal, 5/10. As a percent, 50%. The probability of red, there are 2 red out of the 10 total, so it's 2/10, 1/5. As a decimal, 2/10. As a percent, 20%. Okay, so those are all of our probabilities. Part B, what is the sum of those probabilities? So we're going to add them together. So I'm going to look at the fractions with the common denominator. I'm going to add together 3/10, 5/10, and 2/10. And when I add those together, we get 10/10, which is 1. What color is the selected marble least likely to be? So I have to look at the one with the smallest probability. So if I compare the percents, the least likely color is red. Dealing with this same bag still, was the probability the marble is not red. So every color but red. So that means in this context, it could be either the green or the yellow. So I would add together the 3 and the 5 and put it over the total, which was 10. So I'm getting 8/10. That reduces down to 4/5. As a decimal, 8/10. As a percent, 80%. What is the probability the marble is green or yellow? That's the same thing we just did. Green or yellow means it's not red. So green or yellow would be either the 3 plus the 5 out of the 10. So we get that same answer, 8/10, 4/5. As a decimal, 8/10. As a percent, 80%. What is the probability the marble is purple? So the probability of purple. Well, there is no purple in these colors, so it would be 0 out of 10, 0, 0%. The sample space, which is written with a capital letter S, for an experiment is the set of all possible outcomes for the experiment. So Tom and Nancy are trying to decide who will clean the dishes. They decide to roll a number cube. If the number rolled is prime, Tom will clean the dishes. If the number rolled is composite, Nancy will do the dishes. So first we're going to figure out the sample space. So these are all the possible outcomes that could happen when you roll a die. So they're in these little curly Q brackets. We could get the number 1, 2, 3, 4, 5, or 6. And then you end it with the little curly Q bracket. Between each outcome, you put a comma. So the commas separate all the different outcomes. So for Tom to do the dishes, that was if we get a prime number. So you have to remember what prime numbers are. Prime numbers are numbers that have exactly two factors. So if I underline it, the number 2 is prime, 3 is prime, and 5 is prime. So the probability of Tom, we underlined 3 out of the 6 total, which is 1/2, 5/10, 50%. What is the probability that Nancy will wash the dishes? So the probability for Nancy. And she's washing the dishes if the number is composite, which means more than 2 factors. So Nancy will wash the dishes if we roll a 4 or a 6. So that fraction is 2/6, 1/3, 3/10 repeating, 33 and 3/10 repeating percent. Are these probabilities equally likely, which means are the probabilities the same? They are not. So these are not equally likely. When we compare those two probabilities, we can see Tom was 50% of the time, Nancy was 33.33% of the time. So Tom is more likely to wash the dishes. So Tom is more likely than Nancy. Okay, you write the factors of 12 on a piece of paper and place them in a bag. You then select a piece of paper from the bag. What is the theoretical probability of selecting a prime number? So first we have to find our sample space. What are all the factors of 12? So we have 1 with 12, 2 with 6, 3 with 4. So there's all our factors of 12. So the probability of getting a prime factor. Remember, these have 2 factors to them. So the number 2 and 3 are both prime. So that's 2 numbers out of 1, 2, 3, 4, 5, 6 total, which is 1/3, 3/10 repeating, 33 and 3/10 repeating percent. What is the probability of getting an odd number? Okay, so if I look through my list and underline the odd numbers, 1, 3, and that's it. That's 2/6, 1/3, 3/10 repeating, 33 and 3/10 repeating percent. What is the probability of selecting a 4? So I'm just going to rewrite my sample space so I have it. So my sample space, remember, was 1, 2, 3, 4, 6, and 12. So the probability of getting a 4 is 1 of the 6 total. If I change that to a decimal, it's 16/100 with the 6 repeating, 16 and 6/10 repeating percent. And the probability of getting a 5, when I look through my sample space, there is no 5, so that would be 0 out of 6, 0, 0%. That is impossible to happen. It will not happen. I hope this video helps. Let me know if you have any questions. Thank you.